So good afternoon, everyone. Uh, my name is Eric Stalheim. I'm the Director of Historic Preservation at Kill Architecture and Planning here in South Bend. I'm also the board president of a local nonprofit called South Bend TradeWorks. And for those of you who don't know me, my background is I did my undergraduate bachelor's of architecture at Iowa State University and completed later my master's in historic preservation here at Notre Dame. Progress. Many of you probably know me as having been the first student and graduate of that program. Today, I'm going to be talking to you about the application of technology in historic preservation. We're go over a series of technology today, frequently LiDAR scanning or laser scanning. Digital drawing, photography, lab testing has been around a long time, and we're going to touch briefly at least stress modeling and a little bit about specification writing. So the first topic is LiDAR scanning, or also known as laser scanning. Those of you from that were here on Tuesday would have heard about. Sorry. So we're here. So yeah, we bring your.
If we just mute,
it's that should take care of it. You're good. All right, that should take care of it for you. Again, I'll still be up here. Please let me know if you need anything.
Much better. So, for those of you who are present on Tuesday for Tuesday's lectures, you would have heard a little bit about this from Professor Cruchet, who will have already. She already kind of discussed the basics of this technology. Fundamentally, there's kind of two different avenues here. For architecture and engineering, what we do is a lesser dense point cloud, which is basically a version that is less data heavy. It's called a Matterport is kind of the brand name, but it's a scanner that's on a tripod. You go and you move around your space and it scans a 360 of the space you're in. And then it produces this point cloud and photographs, which are applied to the point cloud in a way. Here on the right of the screen are some images from the data scanner and what they kind of look like, the types of results you get. These are very useful for documenting any kind of building. We use them in historic preservation as they can gather a lot of detail, which when you're in the field doing traditional documentation with paper and pencil, you can only get so much at a time. This allows you to grab a whole lot of information and go back and digest it later as you're ready to do so in the office. LiDAR scanning is a slightly different technology, but related. Is usually more point dense. It's used for outdoor spaces, or archaeological sites, or larger structures like bridges and the like. Nowadays, you can attach LiDAR to drones. Previously, it was usually done through airplanes or other kind of land-based means. And so if anyone's familiar with SciArc, that's a nonprofit that's been around for a long time, since 2003. They use this kind of technology for documenting World Heritage sites. They're very well known for that. DARMA, the Digital Historic Archaeological Architectural Research Material Analysis Lab here at Notre Dame, uses this technology. They're well known for their documentation of the Roman Forum and the Vatican, which Professor Cruce mentioned earlier on Tuesday. When in architecture and engineering, when we get a point cloud for documentation, one of the great benefits is you can drop it right into Revit and build your model, the basis for your drawings right on the point cloud. And it allows you to develop your existing conditions in a very accurate way. And then you can compare them in real time together. You can also do a digital drawing version where you open the point cloud and you can take measurements and then create in either AutoCAD, Revit, however, the drawings that you need to create from that. It's a little bit more analog, but it is something that is done occasionally. From here, another method that's starting to be used more prevalently is drawing on iPads when you're doing documentation in the field. Contractors do this a lot for red lines or as-built when they're doing construction. We are, at least at our office, starting to experiment with doing this where we're doing hand documentation of sites or smaller projects as a way of, if you have a PDF already of your drawings, you can sketch over it, do your measurements, and then it's already saved and ready to go, and oftentimes back to the office before you are. And then Bluebeam is a common tool in engineering and construction, which allows you to do red marks. It's kind of a higher powered version of Adobe, which most designers are familiar with, but it allows you to do it a lot more. You can scale drawings more easily. You can add red marks and notes, and it's all in one document. Next, photography. This obviously has been a technology that's been around for a very long time. We still use it, of course, and rely on it heavily, especially now that photography has gained a lot more resolution. One thing that's really critical is doing detail photography when you're on site. The Matterport and or LiDAR scanning can do so much, but it is always great to have an actual photograph up close, depending on what it is you're studying, especially if you need to get behind corners. Point clouds are directional, so if you have a complicated shape, it doesn't always get behind the back side of things unless you have enough space to get the scanner there. So photographs can be very helpful in that regard, and doing detailed measurements and hand sketches in relation to that is useful. Today, we also use drones. This is very useful for larger buildings, roofs. Roofs are one of the most critical things that we study in historic preservation oftentimes, because that's usually where a lot of failures start. So in our office, we're starting to use a drone. We use a drone on most of our projects, actually. Here are a few examples of roofs or even masonry and other wall conditions higher up on buildings. The drone is really great for getting photographs of these things, and it can be a pretty good high resolution as well. And this is great also early in the design process if you're consulting with contractors. You can share the photos up close with them, and then you get more accurate advice when you're seeking it for specific issues. From there, we're going to go into lab testing. This covers a series of different tests and kind of analysis that is done often on historic buildings that has been around for a long time, most of it, but it is not necessarily always done on every project. The first is paint chip analysis. This is something that in practice is limited to more of your high profile buildings, public buildings, churches lots of times, areas where you historically know there were, or theaters, areas where you historically know there were a lot of stencils or artistic paint on walls and surfaces, and you want to return it to that period of time. So this is most commonly done in true restorations or reconstructions where you're matching something that was to a very specific period of time. When you do rehabilitations or just straight up preservation projects, this is less common. because it usually is beyond the goals of the project. Another aspect is material composition. This is used for plaster if you're matching plaster, or you need to date it or understand what its composition was for like consistency, texture, and thickness. That's also used for mortar. For mortar, it's really important because if you're matching color, it's important to know what the materials are, because usually the materials dictate what the color turns out to be. Another thing is carbon dating. This also is a little less common, but it is done. This is probably more common with archaeological sites, but it is occasionally done for preservation projects. Usually, again, the really high profile ones. Another aspect of preservation documentation is structural modeling. This I'm going to let the last presentation today cover in more detail from the structural engineering experts. But to suffice to say that this contributes to the overall comprehensive documentation of the historic building and the understanding of what the building has been through in its lifetime and what measures need to be taken to maintain and preserve that structure. And last but not least, I want to touch a little bit on specifications. This is a really critical part of what architecture includes. When a project is developed, this is how you convey to a contractor in complement to the drawings what the expectation of the end result is. And you can kind of prescribe materials and practices. The reason I've included it in this is because in recent years, the specifications can be done through online applications, and those applications are starting to include specific sections for historic preservation and conservation treatments. So this makes our jobs a lot easier in prescribing materials and things that are maybe less common in contemporary construction, but are rather critical for historic preservation. An example would be masonry, where lime-based mortar is really important for maintaining a balance in your compressive strengths between mortar and masonry units. And that's all I have. So I'll